Hello everyone. I'm just going to get ready to start on our next step, which is going to be to make our blocks that are going to go into these holes here, and that's going to be to secure our coil so that when we're rotating our rotor, our coil doesn't move. And it's very important to have a very stable coil so we can get accurate readings on it. And I thought about using nylon, which you've seen me use a few parts of that before, so I decided to go ahead and use nylon. But this really isn't a large enough piece to make our blocks out of. So I went and bought another piece of nylon. As you can see, this nylon's pretty big. To give you some sizes on it, it's 12 inches by 12 inches square. And our thickness on our nylon is 3 inches. So this is a 3 by 12 by 12 block of nylon that I'm going to go ahead and cut down and make into some retainer blocks for our coils. Now the reason why I like to use nylon is a very inert plastic. It works very, very well for any type of conductance. It's very smooth, so it won't mar any of the surfaces from any of the tests that we're going to do. So the coil won't be marred or anything by the use of nylon. And nylon is on the little bit of inexpensive side to get in the thicknesses that I need it to be, because it's used in industrial circumstances and things. So they have thicker pieces of it pretty readily available. I'm going to show you how to cut this down. We're going to use one of my table saws to cut this down, and I'll show you how all that process is. And then I'll show you all the steps of getting it all milled down so it's going to be the proper size blocks for what we're using. Okay, so this is the table saw. I recommend anytime that you're doing a lot of plastic work is to use a granite tabletop for it. The steel ones are good, but they can also leave impurities in the plastic and things. That's why I use this to cut big materials down to size. You'll notice the type of saw blade that I'm using here is what's called a flat or true cut, which means that they're not a staggered blade. They're all in a line. And when you have them all in a line, that means that you're not going to gouge out your plastic and it won't cause the nick marks. You'll also notice that I have a splitter engaged and I have my fence. Be sure to read, understand, and follow all the safety regulations and rules that come with your power equipment, and that'll greatly reduce your risk of possible injury. Now, what I've set this at here is the same thickness as our material, so we're going to come out with a cube. And once we get that done, then we'll cut it down to length and we'll finish out the rest of the work. But let me go ahead and show you the first cut, and then we'll move on from there. The table saw will be a bit noisy, and you may see some vibration in the camera. I apologize for that. And always be extremely careful when you're cutting plastic so that none of the filings comes back in your eyes. Always make sure you're wearing safety glasses, safety goggles, a face shield. And I do have a dust collection system that I have. I did not have it on during this cut because you wouldn't have been able to hear me talk. The other thing is you will have some loose filings like this that come off of it, and they're going to collect inside your blade and everything like that. So make sure you clean up your materials and your tools before you do your next cut, just to make sure that you don't have anything wound up where it shouldn't be. Now you'll notice the difference between the cut that I have done and the factory cut. I'm not sure if you can see that. I'll try and put it in the light a little bit, but you'll see the hex marks that are on this cut versus the smooth cut that I did on my saw. Now the reason why this is so much smoother is because of the type of blade that I'm using here. It's a very strong carbide tooth saw blade, and they're all directly in a line, and that's the difference between a staggered cut and one that's all in a line. So I wanted you to show that. This will be a lot easier for us to true up. So you'll notice that our size here is 3 inches by 3 inches. So we've got an exact cube so that we're good to start doing the rest of our milling. And I'll show you that in just a minute. Okay, so our next part is going to be to cut this block into two pieces that are 5 3/4 inches long. That's going to support our coil, and it's going to give us a tie-down block for the back half of our device as well. And as soon as that comes to a stop and the blade stops completely, we can get our little residual piece out. Never reach inside the saw while it's on. Always make sure that it's off. If anything happens or jams or anything, just step away, turn the machine off, and then come back in and check it. Now, you can see both of our sides are exactly the same length. They're the exact same width no matter which way that we turn it, so that they'll all be the exact same size. Now, our next part is going to be to make a slight cut here, and we're going to bore out this top piece of the material. So we're going to cut it here, and then we're going to cut it down the profile here, and that'll give us a nice resting place for our coils to go, and that'll also make a place where we can put our block so that we can tighten down our coils once we get them inside of the block here. And we're going to do that in a couple of different steps, and I'll show you all of that as that goes in. But this right here is our primary step here.